snap system of the particles and rotations motions. When whose particles maintaining the same relative positions with respect to another particles of the same body, even under the action of the external unbalanced force, is known as the rigid body. The point at which whole mass of body is supposed to concentrated in the order study of the motion of body according to the Newton's law of motion is known as the center mass of body. Ideally, a rigid body is one for which distance between the particles of the body does not change even if there are force on them. A rigid body fixed at a point or along a line have a only rotate motion. A rigid body is not fixed in some way can be have either pure translations or through combinations of translations and rotations. In rotations about the a fixed axis, even particles of rigid body moves in the circles which lies in the plane and perpendicular to the axis has its axis center on the axis. Every point in the rotation rigid body has same angular velocity at any instant of time. In pure translation, every particle of body moves some velocity at any instant of time. The velocity of the center of mass of a system of particles is given by V is equal to P by M, where P is linear momentum and P is equal to mv for system. Center of mass moves as if all mass of the system is concentrated at this point and all external force act at it. If the total external force of system is zero, the total linear momentum of system is constant. Linear momentum of system of n particles of origin L is equal to summation of the Ri into Pi. The torque or momentum of the force on the system of n particles above the origin tau is equal to summation of Ri into Fi. Fi act on the i's particles including the external as well as internal force. Assuming Newton's third law, force between two particles along the linear joint particles, we can show tau instant is equal to 0 to T of TL is equal to tau external. A rigid body is the mechanical equilibrium if translational equilibrium is total external force on its zero summation Fi is equal to 0. It is the rotation equilibrium. For example, total external torque on it is 0 summation of tau E. It is rotation equilibrium. Total external torque on it is 0 summation tau I is equal to summation Ri into Fi is equal to 0. Some relations for the center of mass of n particle systems. SCM center of mass is equal to MIXI M2 into x2 plus mn into xn upon m1 plus m2 plus mn. x1, x2, xn is distance from the center of mass m1 and mn.